Okay, in this video we're going to be talking about convergence and divergence of geometric series. So what I want you to do here is recall a little bit of facts about a geometric series, and that is when you're looking at the common ratio r. For an r, a common ratio, and we're talking about the absolute value here. If the absolute value of r, the common ratio, is less than 1, then we can say the series converges. When the common ratio r, absolute value, of course, again, is greater than or equal to 1, we can say then that the series diverges. So we're looking at two geometric series here. The first one is from 1 to infinity. It's 1 over 10 to the power n. So what we're going to do here is we are going to look at it and we're going to identify that common ratio. Well, we see here that it's going to increase by a power of 10 in every successive element of this series. So what we're going to do is we're going to say, okay, well, r equals then 1/10, okay, because it's in the denominator. And so what I'm going to say here, and the comment I'm going to make, is that the absolute value of r then is actually less than 1. So then the conclusion that I can make here for this geometric series is that it indeed converges. All right, so this one does converge. All right, so now we're going to look at the next one, number 2. We're going to go from 1 to infinity. We have 1 over the natural log of 2 to the power n. This one is very similar to the one that we just looked at. Here in this case, we have 1 over the natural log of 2 as our r value. Well, you'd probably want to use a calculator for this to figure out what exactly that is. And when you do something like that, you're going to find out that you end up getting something like 1.44 approximately. So what can we say then about this r value? Well, what we can say about this r value is that it is actually greater than or equal to 1. Therefore, we can make the claim then that it diverges. All right, and so it's as simple as that. All right, there are other things you can do. You could perform an integral test, for example, to go about doing this one. But it's as simple as this, that we know it's a geometric series. We can make some conclusions based on the common ratio r. And so again, just read over that definition there at the top and understand what it means for it to converge and what it means for it to diverge. As always, I hope this video was helpful. And remember, like and subscribe.